Welcome to Ask and Learn.
Okay, let's draw the capacitor. This side has dielectric inserted, and the length of a dielectric inserted is x. Total length is L, and it's a square plate, so its width is also L. Now, area here is L times L minus x, and area on this side where dielectric is inserted is L times x. So capacitance then, since when arrangement is somewhat like this, you have two capacitors in parallel. That means you will add up C1 plus C2, because in parallel combination capacitance just adds up. Now C1 is on the left, this is C1, and C2 is on the right with the dielectric. So let's write down the formula for C1 and C2. So you know that the formula for capacitance is area 1 times epsilon naught K 1 divided by distance, that is separation distance D, plus again area 2 epsilon naught and K2 divided by D. Let's substitute the values. A1 is this is A1, so L times L minus X epsilon naught K1 is 1 divided by D plus A2 is L, let me write that again, L times X epsilon naught and K, since value of K2 is K, divided by D. Now let's simplify this. From this equation you can see that on both sides you have factor of Lx. So let's expand it so that we can easily do it. L square minus Lx times epsilon naught divided by D plus Lx epsilon naught K divided by D, which is equal to L square. Let's take L square epsilon naught. I'm sorry about this. Since there is a factor of L in everything, let's take L epsilon naught divided by D common from everything. Then we are left with L from this first term. The second term we have X, and this term we have xk. Now we can simplify this bit more by taking factor of L common again. Then we have L square epsilon naught divided by D 1 minus, so we can write 1 plus, since x is common in both these two terms, have x common, so we can write x minus k minus 1 x divided by L. This factor of L comes from L square in here. So this is the capacitance of this system. Now next task is to find energy stored if the potential difference is equal to V naught. Energy is just half C V square. So let's just substitute the values to get the answer. So from part A we know that it's L square epsilon naught divided by twice D now, because of this factor of 2 here, multiplied by 1 plus K minus 1 times X divided by L V naught square. That's energy stored. Next task is to find the magnitude and the direction of force exerted on the slab. Now, this energy is also the potential energy. So U equals E. Let's use that. The force is equal to negative gradient of X, gradient of the potential energy. So if you take the derivative of U with respect to X, you can see that this term is 0 because it's a 1. This is for plus sign. So, but this term is not 0. So this is the one which will give you the contribution. So X derivative of X is 1. So we are left with remaining terms. So remaining terms that are non-zero are L square. L square epsilon naught divided by D come from the fact they are outside, but they are still multiplying the factor of K minus 1 X divided by L V naught square. So this is the force, and the negative sign implies that the force is acting to the left.